Welcome back. Today we're going to work on assemblies, which are basically a collection of individual parts that we've put together. One reason we might want to do this is to make sure that all the parts work together and then it moves the way that we want it to do so. So this is the assembly that we're going to make, and I'm just going to show you. We're going to do a quick video on it moving to basically show it off. So the assembly is made of these four parts. And these four parts can be found on eLearn. So that's the full video. So if you go to eLearn, you can find the parts for assembly. Just click on this. You can download the folder, put these files somewhere where you can find them as individual files in this folder, and then we'll open those up in SolidWorks. Okay, so we'll go back to SolidWorks. So I'm going to close this, and we're going to save all. And we're going to start from scratch. So I'm going to hit a new, and this time instead of doing part, we are going to do assembly. And this opens up this window, and the first thing it wants is basically, well, you want me to do an assembly, so let's pick a part. We want to start with this base, and it's critical that you start with the main part that forms the structure of the build, because the first part that it puts in there will be kind of the reference point for everything else. And that way you won't end up with something weird where something's not supposed to where you want it. So I always start with like the key thing, the thing that stays still in the build, because everything else is referenced from that. So that in this build is the base. So open that up and it will appear on the screen. Here I can move it around. So put it basically in the middle is a good place to put it. Okay, so now everything is going to be referenced from this single base. Now I want to insert more parts because an assembly with one part is not very interesting. I could add more of the same part. You can add lots of copies of the individual part. But now I want to click on this insert components and then insert components. So we could do any of these, but this is the one that we want for this application. Okay, and then it brings up my open menu, and I can select all the other ones at the same time. So we did arm, and then to select the other ones, I held down the control key, the pin, and the sleeve, or you can keep doing this individually. And so it's going to start opening up all the parts individually, and I'm just going to stick them somewhere. We can move around later. Pin. Okay, and my sleeve. Okay, they're overlapping, but I can go up here to move component and move things around a bit. Go to zoom to all, and then move this component. And we can rotate individual components too. That if I go up here to move components, it's also rotate. So eventually that is going to want to go into that sleeve. So it kind of depends on where you grab it. So move component. And we'll find that there's more elegant ways to move these components around and get everything lined up exactly how you want it. Because as you can see, it's pretty hard to like move things around. All this dimensions for all these components are in the written lesson. So if you want to try to construct them yourself, you're more than welcome to. Okay, so we got that one in, we got all the parts in, and the next thing we need to do is try to start putting these things together. Okay, and in this, to put things together and to have things referenced to each other, it's called mate. So we're mating different parts together. That's up here in the assembly ribbon. So next to the insert components is the mate feature. So I hit mate, and this is a lot like the reference feature we did when we were drawing parts. First thing I want to do is put this pin in the base. And so to do that, we want to first take a look at what our mate dialog box looks like. So mate selections, and this will be the names of the mates, names of the surfaces or curves or lines that we want to join together. And then here's all the different mate types. So coincidence means touching each other, basically. Parallel means parallel, perpendicular means perpendicular, tangent means, they pretty much mean what they say they mean. Tangent means a circle and a line are tangent to each other. Concentric means circles have the same center. Then we also are going to use a distance reference and an angle reference that we can specify individual numbers. And this will list any other mates that are for the part. So that's the main part of the menu. So we want to get this little pin in that base. So I'm going to use the zoom in to an area tool and zoom in a little bit so you can see better what I'm doing. So there's lots of ways we can do it. Is that we can make this curve on the outside of this cylinder coincident with the inside curve. But part of what we're doing when we're drawing is what's called the design intent. And that is by the choices you make and how you draw something, you kind of tell the people that are going to make it how you intend it to be built. So to do that, and when we make mates, we generally want to pick the type of mating first and then the surface. So here I want basically the circle that makes up the pin to be concentric with the circle that makes up the hole. So I'm going to hit concentric, and then I'm going to select the outside circle. You see it turns orange. So I could select that one too, but this one's easier to select. So I'm going to select the outside of that circle. And then I want it to be concentric, or coaxial, with this circle. And I could really pick any of these circles. You can see as I hover over them, they all get highlighted, but I'm just going to pick this one. And then it moves in there, and then hit check. We can do multiple mates without this closing, but I'm going to rotate this a little bit so you can see what happens. I got to close the mate to do that. Okay, rotate view. So we can see the pin's in there clearly, but not in very well. It's going to fall out. So now we need to basically slide the pin down. And we have several options to do that, and I'll show you a couple of the options. We can do that. So we do mate again. So we can do coincident of this surface and this surface. The outside surface of the base plate and the outside surface of the pin is one option. And that's nice if we never want to change it. But if we ever wanted to have the visualization, the movie, move it, then we might want to choose a number. But since it's 0 and I'm not going to want to move it, I'm going to hit the coincident button. And so I'm going to say that this surface is coincident with the surface on the base, so that means they're touching, and then we can hit the check mark button, and that hopefully you saw that slid the pin into that base plate. Okay, so then we hit check again, and we want to zoom out some because the next thing we want to do is move this sleeve and move that hole onto that pin. Now clearly this is not how you would assemble it if you were assembling it from scratch, because I'd have to put the pin in for the sleeve over there before I move the pin. But as you can see, this is all just bits and pieces. It's all just bits and imaginary, so we can maybe move things through each other. It doesn't really matter. So you don't have to assemble things in the perfectly correct order that they would in the real world. Also note though that part of the reason to use an assembly is to make sure things fit together and that the parts can move independently, that things don't run into each other. But to do that, we have to specifically tell it what is running into each other. Otherwise we can move parts through other parts. So I can move this component and I can move it, through this part, and it doesn't matter. Obviously, I couldn't do that in the real world, but we can in here. Okay, so we're going to use a similar strategy for mating, for putting the sleeve onto that pin. So I'm going to mate the concentric circles again. So hit the mate button. It's doing a little processing. Might have something in there. I don't know what that is, so I'm just going to clear that out. And I'm going to use the same strategy of I want concentric, and I'm going to hit the circle and the circle here, and then it moves concentric. So I guess it's concentric. They are coaxial, but they're clearly not in the right place yet. So if I rotate the view, it's clearly not in the right spot. We want to move it over some. So we have a few choices to do that. So we'll do a mate again. And so what I can do is move the outside of the sleeve to be coincident with the inside surface of the bar on the base plate, or I can move the back surface to be coincident with this. So there are a few ways to be able to kind of select a surface you can't see. So I'm going to show you one of my favorites here. So I'm going to hit coincident because it's usually best to select what type of mate you want first, and then which two surfaces you want to mate. So I'm going to mate the front side of the sleeve to the back side of the base plate here. So we can't really select it, right? So we could go up to wireframe, and so we could see it, and then it's a little easier to select, but still I'm not really able to select it. So we're going to go back to the standard view. And the easiest way to do that is actually right click in an area that is over where the surface that you want to select is. So it wouldn't work out here. Like if I selected here and did select other, then we have the back of that face, which is not the one I want. But if I am in an area that is over the back face, then I can right click and hit select other. And then I can select that back face. I can select all the other ones, but you notice that that back face is highlighted. And we can also highlight it in here. So there's two places where we could select that back face of that plate. And you notice that it moves into position. So hit check mark twice to get out of that. And now we can rotate our view and we can see that that is nicely in place. And so I'm going to zoom to fits again, and we're going to sit on the right, the front side, so we can see it. And then we can move this component again. And now you can see that I can't move it off. That now that those are defined as mated together, I can't separate them unless I delete those mates. Okay, the last thing is to get this arm inside of this sleeve. So notice we're building the parts from the base out and assembling it that way. Okay, so there's lots of different ways I can do to get this aligned. I could make this side parallel to this side. I could make one of these edges parallel to one of these edges. It doesn't really matter which way you do it. So I'm going to try it a couple different ways. That we need to get the sides parallel and the tops parallel in order for it to be in the sleeve correctly. So now I'm going to select parallel, and I want this front face of the sleeve to be parallel to the front face of my arm. So that moved it parallel, but that doesn't really look right yet. So we're going to hit check mark. And then I also want this face to be parallel to this top face. Okay, so we're getting closer. So if we rotate it, we see that we're clearly not in. So now I got to figure out how to get this actually into the surface, into the sleeve. So that I need another mate. And so I'm going to do something similar like I did to mount the sleeve onto the base, is that I want this front face to be coincident with the inside of this tube. So we're going to select coincident, and we want that face. And then again, I'm going to right click on the area above where the back face would be, so I can see it. So I can select it from here. It turns nice and orange, or I can go through and select surfaces from here. And you notice it highlights each one as we go through. So I want that back side of the near wall of that sleeve. And then we move in. Oh, and clearly it's not quite correct. So we need to make another one coincident. So we're getting closer. Okay, so we now need to mate the bottom of this coincident with the bottom of my arm. So again, right click and hit select other and go to the bottom of the arm. Okay, so now it's in, but it's clearly running into itself. So select that. We see the wireframe that and we rotate it, hit X over here, and rotate the view, is that my arm is way past the end of the sleeve. So even though the sleeve has an end here, the arm is way past it. So that is not going to work very well. So I'm going to move that arm out. It's going to make my life easier. I have to be on the wireframe. Out of the wireframe. Okay, move component. So I want to select this guy and move him. Okay, it's moving. Okay, it can be difficult to do sometimes. Okay, let's see if I can grab it or not. Might have to grab it from the end here, rotate view. So sometimes if it goes in weird, it can be kind of a pain to get out to where you want it. Okay, so now I can move it in or out, but there's nothing preventing it from going all the way out the back. Whoa, whoa, okay. So we want it to look something like that. And this is a part of the component that I'm going to want to move during the animation. So we're going to hit mate. And instead of using coincident mate, I'm going to use the distance mate so I can actually define what that distance is during the animation. So I'm going to hit the top surface here, and then I'm going to zoom in on here so you can really see what I'm doing. I'm going to select this top surface here, and we're going to say that that's going to be, we'll start out at 10 millimeters. So you can see that it'll pull it back out some. Okay, that looks pretty good. So it's sticking out 10 millimeters, right? And now if I wanted to go try to move it, I wouldn't be able to move it out. It would move the arm up and down, but it would not be able to move out. Cool, getting there. So we want to do one more mate, because another thing I want the animation to do is move this arm up and down. So this is what I'm going to use, an angle mate. And we're going to want to start it straight up. So it's 90 degrees. And I'm going to mate the base, the top of the base with the bottom of the sleeve. So the top of the base, and then right click, select other. I don't know, so I might want to rotate the view a little bit to make that a little easier to select. Okay, so now I'm going to have a bigger area to select from. If you look at the wireframe. Okay, so if we have the wireframe, there's a much bigger area here that I can select over. So do mate. And so again, we're going to do the angle at 90 degrees. And then we're going to scroll up and we're going to select the top of this surface. And then we're going to right click over that bottom part and hit the bottom. There we go. 90 degrees, so it went straight up. That makes sense. Okay, double click the check marks to get out of the mating, and you'll see now that all of our parts are in here. We could go through and edit these parts here if we wanted to. And here is all of our mates. So if you decided that you didn't like one of these mates, you notice that as I highlight over them, it tells me which parts are mated together. But if I wanted to get rid of one, I would simply right click and hit delete, or I could go up to the edit menu. It should bring us back into that edit window. Okay, so if you haven't already, make sure you do save this assembly. And so I just saved it as a file, save as W6 arm assembly. So it's the second one I'm going to do. I'm going to add like a 2 to it just to make it a different file in case I need to come back and change something. Okay, so we're going to go back to our standard view. Looks nice. And we're going to zoom out so that we can see everything, and then our movie will show everything. Okay, the next thing to do is make the movie. So you go down to the bottom window, and right below the coordinate system is motion study. And so that brings this up. And what we want to do next is scroll down and open up our mating window, because these last two mates that we did are the ones that we're actually going to want to change. So, okay, so these are basically our cues, and we can really drag, move these out to any time. But what I want to do is first copy the mate that I want to change and paste it over here somewhere. Okay, so I want to first move the, so I want that one way out here. And I want to change the angle first. So what I want to do is lower it, pull the arm out, then push the arm back in, and then raise it up again. So I want to copy this and paste it over here. And I want to paste it over here again. Okay, so now we got several keys, and you can move it around depending on how long or short you want things to take. Yeah, so, okay, so now I can, so to move it down, I need to change the angle. So the angle here is set at 90. They're all set at 90. So double click, I can see it's set at 90, right? And then I double click. So we scrolled up again, scroll down. Okay, so double click on this first one, and I want to change it, I believe, to 180, because we want to rotate it in that direction, depending on how you exactly put these in, right? And so we can test the movie. We can go up here and hit the calculate button, and it will go ahead and do the calculation and show us our movie thus far. So right now it goes back up because it knows that the other time points are set at 90 degrees. Okay, so we angle. Okay, we want to move this one out. And we want to move the distance in. So now that I'm at 0 degrees, now I want to be able to move out this arm. So we can decide how long we want that to take. And so if I move this back down, then that is the move to change the angle is going to be shorter. So I'll put that one right there, double click on it, and it said 10 millimeters. So we wanted to go, it can go out to 300. So we'll just do 200 millimeters, call that good. Right, and I want it to also come back in before it rotates up. So I can copy this and paste that again out here. Okay, I want that to move back to, we'll just do something a little different, 15. That looks good. Okay, I gotta scroll down. Yep. And then I'll paste it at the end to make sure it stays at 15. Yep, okay, so it looks safe. Okay, now I hit the calculate button again, and it's gonna go through pretty quickly, and it's not going back in as fast as I thought. Oh, there it goes back in. Okay, and then comes back up. Okay, so if you don't want it to go in and out while it's moving, we gotta add a couple more time points here. So here was at fully bent down, and it's starting to go back up in this whole section. So if I want to stay down, I gotta copy this and paste it out here so it stays down while it's pulled out. Okay, so we recalculate. There you go, and then it moves back up and makes a happy sound. Okay, so we're going to scroll down, make sure everything looks right, and we're going to play that movie. So then it bends down and pulls out. pulls all the way out. It then scrolls back up. And a fine movie. So this is where we save it. And we want to do rebuild and save the document. And then we want to export our movie. So we hit the save animation button on the motion manager toolbar. So here is the full toolbar. This was our calculate button. This is the play from start. That's just playing. Then this is our save animation button and our animation wizard. So that'll give you a wizard on how to do some more animation steps. I haven't used a whole lot of these, but we certainly can explore them. So we want to hit the save, and this is where you hit the figure out what type of file. Right now, the MP4s are pretty standard files for making videos. You can change the image size. So now you hit save. So recalculate before saving, sure. It's gonna run through it again. And then save it. And it's absolutely fabulous. And so we want to go into our File Explorer and basically figure out where that saved it. SOLIDWORKS drawings in my assembly folder should now have saved a movie. So if I open up this movie, then we have a little movie of your parts moving. And see it cut it off. You can fix this by basically making sure that you have the part situated in the window where it doesn't run off. Okay, that's it. All done. Hope that was fun. So hit save again. Yes, rebuild. And that is the end of this lesson.